All right. So, again, just a reminder, these are some rules that we've learned. Product rule, quotient rule, and chain rule. And I'm just a reminder that product rule happens when I have a function times a function. And the derivative of that, did they write fig plus gif or did they write gif plus fig? They did gif plus fig. Does it matter? It doesn't because it's addition in between, so it makes no difference. When it does matter is when we're doing division. This one has to go low, D high, because then there's minus. High, D low, all over low, low. If that helps you to write that out, that this is technically low, D high, minus high, D low, all over low, low, you could write that. But if you don't need to, you're good. And then what they do over here, we have f of g, and look what they did. They took the derivative of the outer, they left the inner, times the derivative of the inner. Cool. So all we want to practice on 3-5 is just like, when do I use which? And I'm here to tell you, I think that you guys are better than this than my kids last year already. I feel like you guys are better at knowing which one to do. So kudos to you. It's not a slam on them. I'm just trying to let you know. Okay, this first one. What? Well, let's jump. Does anyone have one of these? They're like, I think that one uses, I also just threw like basic rules in there. Say that again one more time.
The y equals 3 over x to the 4th.
3 over x to the 4th. What were you saying that one would be?
I would have done product.
Yeah, well,
This would be quotient rule if we left it like this, right? Because it's 3 divided by. So this could be quotient rule. Is there a way? Biscuit would do quotient rule on this one.
there's a better way to do it.
How could we do it?
It's 3 times x to the negative 4th.
3x to the negative 4th would leave us to like that power rule. I think you were trying to say power rule when you said product rule. Yeah, if we rewrote this one, it'd be 3x to the negative 4th, and that derivative would be what, Coop?
Negative 12 times x to the negative 5th.
Yes, sir. And my man Biscuit, if he did quotient rule over here, he's still going to get the same thing. I kind of want to show it because will it simplify the same way? I'm not sure. If we went low, D high, minus high, D low, all over low, low. Yeah, cool. Right? Low, low. Did I do that right? Low, D high, minus high, D low, all over low, low. Okay, if I simplified this, this is going to get me a 0. And I'd get negative 12x cubed over x to the 8th. Why is this getting me different? Oh, yeah, no. Silly me. Do you agree that that is negative 12 over x to the 5th? And isn't that what Coop got me over here, negative 12 over x to the 5th? Any others of these, what would we have to do for this one? Chain rule. We've got an outer and an inner. So I'm going to go put that one over here. We might not have room to do all these on our page, and that's okay. But I'm going to say this was y equals e to the tan of x. What would the derivative of that get me? The derivative of e to the anything? E to the tangent of x times, nice, the derivative of tangent is secant squared. So we had an outer and an inner. The derivative of e is always the e. Leave the inner. The derivative of the inner was secant squared. That's good. So we've done 2 of these. This one was chain rule. This one was either power or quotient. Do we have another? I see a couple more chain rules. Anyone see any? I see, wow, quite a few chain rules. Anyone else see another chain rule with an outer and an inner? Natural law, y equals ln of 5x squared plus 1. You're so right. That's a chain rule. So this was a chain rule. This is a chain rule. And again, we don't have to do all of these, but this one I think is a good one to practice. How do you do the derivative of natural log? 1 over
5x squared plus 1.
5x squared plus 1. Keep it going, Coop. Keep it going, Coop. Keep it going.
Times 10x.
Very good. There's that chain rule killing us. Let me say that one more time. It's 1 over this quantity every time times the derivative of that quantity. Cooper, what if you just said 10x over all that stuff?
That's also good.
That is also good. I agree. 10x. Give me a product rule one. Oh, which rule would I need to use with that one?
Well, you need chain and quotient.
Oh, shoot. Chain and quotient rule. He's so right. We'd need chain and quotient rule. I'm going to go throw this one under, I'm just going to, maybe we would even just write it next to it because I would imagine you all are running out of space. This one would be chain and quotient. Actually, I would do quotient. I'd write quotient rule first because that would be what we'd have to start with. Quotient rule, and then we'd have to go chain from there. And we don't have to actually work that out because I don't think we're going to have enough space. What's another, okay, let's just do it. What do we think this one is? Let me zoom this in. What do you think this one? This one needs quotient rule, okay? Because we got division. Bless you. What about this one? Product rule, because we've got one function times another function. This one would be product rule. Bless you. Ooh. Inverse cosine of 2x plus 3. Chain rule. It's going to be one of those new derivatives of inverse trig functions, but that's just a chain rule because we got an outer and an inner. Another product, right? X times inverse sine. This would be a fig. So we got another, I'm writing chain, but I meant to say product. Okay, so we don't have to work through all those, but I just wanted us to talk through what we would have to do. Let's just go apply some things. Let's go get busy. Let's go do it. On this one here, they want the derivative of f of ln of x. Do I even like this? Here's what I want you to focus on first. Can we just focus on this? Meaning, go find this derivative, and then we'll apply it to my function. So, this right here, Coop, if we're saying what's the derivative of this, don't you agree this has an outer and an inner?
Yeah.
And Coop, I'm not saying you're wrong. I'm curious. I'm curious if it, let's see if it would get us the same answer, Coop. How would I take that? What would I get the derivative of this? What would just this be? Again, don't even look at that stuff. This is non-eventful right now. F prime of ln of x times, shoot, that's great. He says, yeah, derivative of the outer, I left the inner, times the derivative of this inner, the derivative of natural log of x is 1 over x. So good. So then, this got real complicated real quick. We've got to actually, Coop, go plug in ln of x into what?
The derivative of
Yeah, we got to go plug in L of x into f prime. So let me now unscratch this out. What is f prime?
2x plus 2.
F prime of x is 2x plus 2. And we've got to then go take my ln of x and plug it into that derivative. Coop, would you have been getting the same answer if we did it? No? 2 times ln of x and then plus 2. That f prime of ln of x would just get me this. What do I still need to multiply all of this by?
1 over x.
Yeah, I still need to bring this guy down. This thing, 1 over x, needs to be brought down. So I've got all of this times 1 over x. Say it again, buddy.
You should put it all over x.
Totally. Because this is really just over 1. So if I multiplied those across on top, 2 ln of x plus 2 times 1 would just get me 2 ln of x plus 2. And 1 times x on the bottom would get me an x. Is that an answer?
Yes,
It's A.
Yeah.
Whoops. In what order should we apply the rules of the derivatives? Meaning, just like you had said earlier, Bob, you were like, chain rule, then product rule, or chain rule, then quotient rule, then chain rule. Yeah, what order, how would we take the derivative of this thing? Chain rule, then product rule. He's like, I've got an outer, then an inner. Agreed. If I've got an outer here and an inner here, we got to go take the derivative of the outer first. And this is using chain rule. What would the derivative of my outer get me? E to the x, yeah, it's the same thing. x sine of x, times the derivative of the inner. What do we have to do now to take the derivative of the inner? Yeah, we gotta go do product rule. So now, first we did chain rule, and now we gotta go do product rule. I'm gonna even just put that right here. We gotta do product rule. Blah. We got this. What would f prime be?
1.
1 times g. Very good. Fig would just be sine of x. Could be 1 sine of x. That's fig. Plus GIF. Nice. The derivative of sine is cosine. Cosine of x. And then you threw that x. I like how you said it, Ritzy. You said x cosine of x. And I like putting it like that so that people don't think that this is going to be an x squared. You know what I mean? He said this is g prime times f. And that x is really a coefficient. So we could put it right there so that people don't get confused. Yeah? Okay, that's a lot. I left you a lot of space and only gave us one line to do that. Okay. How about this one? What rule are we going to do first?
I'd say product.
Yeah, because we've got one function times another function. Okay, fig. So I'm going to do product rule first. What's f prime? Nice. Times the derivative of that exponent? Good. It's just e to the x. Fig would be e to the x. Do you agree I could say that this is sine of x to the 5th is my g?
Yeah.
Yeah, and I think that that might help us to write it that way to help us with our g prime. G prime, I got to go take the derivative of this whole thing now. Say that again.
5 times sine of x to the 4th times cosine.
Exactly. You said I got an outer and an inner. So now I got to do some chain rule. Now I got to go do some chain rule. And he said the derivative of the outer is 5. Leave the inner. Take that exponent down by 1. That's the derivative of the outer. We left the inner. We got to multiply it by the derivative of the inner, which is cosine. This right here was the chain rule and g prime.
What about, I was about to say, what about the other?
I'm so glad you did because we got to have a GIF, right? That we got to have that final F. And then, Bob, maybe your final answer is 5 e to the x times that slop. You could put that e to the x next to the 5 if you wanted to. Okay, what rule are we starting with here, y'all?
Quotient.
Quotient. What's low? Thanks, bud. Low was e to the 2x plus 3. D high.
Cos of x.
Good. Low d high minus high
Sine of x.
d low. E to the 2x plus 3 times 2. Where did that 2 come from? The derivative of my exponent. So let me say that one more time. Low d high minus high d low. This is all d low. The derivative of e to the anything will be e to the anything times the derivative of the anything. All over low. Here we go. How about this one? Just a reminder, arctan is the same as inverse tan, if that helps you. I like inverse tan because it's less to write, personally. But you guys, we got to start memorizing these rules. Derivative of inverse tan, it's my favorite, would get me what? 1 over 1 plus e to the 2x squared. Ooh, yeah. So, real fast, ready? It's 1 over 1 plus this angle squared times the derivative of this angle. Be careful. What's the derivative of e to the 2x? E to the 2x times another 2. E is like the gift that keeps on giving, isn't it? You know? This was just bringing you down. It's 1 over 1 plus u squared. Here's my u. We just brought that down. Then this is the derivative of my u. The derivative of e to the 2x is e to the 2x times 2. Maybe some people are jumping to writing it like this, 2 e to the 2x. Maybe they're doing that. Is that an answer?
Yes. It is. It's B.
Yeah, I was going to say, I'm just looking at the numerators. This one, they tried to do like a little inverse sign on it, so I'm digging that. Yep. When I've got a power to a power, they get multiplied. 2x times 2 is 4x. People, you guys are crushing this. Ooh, this is really putting all of Unit 3 together.
Yeah.
I've got a piece of candy if someone can get just even this derivative right. Hold on, you can't do it first, but because you got the candy yesterday, Koopy. Bob, did you get the candy yesterday? Mark says, yeah, he did. Mark, you want to do it instead?
No.
No? He said, no, thank you. Deanie.
1 over 2x plus y times 2 plus dy dx.
Yes. Now, how many people are like, what? Dean, I want you to say that one more time, a little slower.
1 over 2x plus y times 2 plus dy dx.
And where the heck did 2 plus dy dx come from?
2x plus y.
Yeah, the derivative of 2x is 2, and the derivative of y always has a dy dx with it, no matter where it is. Dean, that was so good. Equals derivative of x, Dean,
1.
and the derivative of 1. Good. They said, what is dy dx? So you guys, we have to get our dy dx by itself. What do you want to do first?
Multiply by 2x plus y.
I'd get rid of that denominator, exactly. Multiply both sides by 2x plus y, and then your denominators go poof.
Hey.
And I'm left with 2 plus dy dx equals 2x plus y. Are we almost there?
Yeah, you just subtract.
And then you just subtract that 2 over. 2x and a y minus a 2. 2x and a y minus a 2? This question is literally disgusting, so we're going to do that. It's gross. We don't need it. Here we go. Which of the following does not require chain rule? And which one does not require it? Any ideas? Which of the following? Which of the following does not require chain rule? Oh, this is interesting. They almost just got me. Which one? Okay, give me one that does require chain rule, would you say?
A.
A definitely requires chain rule because that's an inner.
Same thing with D.
And D also requires chain rule because that's an inner. So A and D are out. Between B and C,
What?
they look kind of similar. What were you going to say, Tatum?
Well, don't you have for like the exponents and stuff? Don't you have to use chain rule for those?
So this would be more like that power rule stuff, like 40x to the 9th. That'd be power rule, and you're good at that. 18y to the 2nd times something here. dy dx. And that dy dx is considered that quote-unquote chain rule because this would be my outer and that would be my inner. So that's one. Which one of the following does not require chain rule? Why is C not requiring chain rule? Y is by itself, exactly. So if you want to even write yourself a note, that'd be like 18y squared dy dx, and that dy dx right here is considered that chain rule that we often forget about.